Welcome back. Until now, we have used operators like plus or minus with built-in types like integers and strings. But in Python, you can extend this functionality to your own custom objects. This process is called operator overloading. It allows you to define exactly how an operator behaves when applied to your custom classes. 1. What is operator overloading? It is a specific type of polymorphism where different operators have different implementations depending on their arguments. To achieve this in Python, we use special predefined methods known as magic methods or dunder methods because they start and end with double underscores. 2. Common operator mapping. This table shows how Python maps familiar operators to their corresponding dunder methods. For instance, when you use the plus operator between two objects, Python internally tries to call the double underscore add double underscore method. If we implement these methods in our class, we can define our own custom logic for these operations. 3. Implementing custom addition. Let's create a point class representing coordinates. By implementing the double underscore add double underscore method, we define that adding 2 points results in a new point object where the x and y values are the sums of the original points. The other parameter refers to the object on the right side of the plus sign. 4. Testing overloaded operators. Now, when we define P1 and P2 and write P1 plus P2, Python automatically calls our custom method. Without this method, Python would throw a type error because it wouldn't know how to add 2-point objects. This makes our custom classes feel like built-in Python types. To summarize, operator overloading is a high-level feature that provides intuitive interfaces for your classes. You may use this to perform coordinate math, combine bank accounts, or merge data structures. In our final lecture on polymorphism, we will explore runtime polymorphism, where the exact method executed is determined while the program is running. Our next lecture 19.05, Runtime Polymorphism. See you there.